Can you see that?
Yes, Ken.
All right. Okay. All right, so let's see. I think some of you have seen these slides already, but this will be interesting to some of the new people, I think. Okay, so basically, okay, interesting. I think I'm going to have to move these people out of the way. Move you off to the side. Okay, so I've been thinking about what we want to do in this new open source environment, and how we want to proceed and grow based on what we have so far. And it occurred to me that the strength of GenevaERS is not necessarily the software, which we've invested so much in for 30 years, but the design, which actually could be written in a lot of different languages. And the basic design is this data model that we have about having predefined lookup paths, which is kind of unusual. And this logic table, which is kind of this intermediate structure between readable language and then machine code. And then our extract engine, MR95, which has this basically a logic text compiler, which takes the, logic table compiler, which takes the logic table function codes and translates them into machine code for easy execution and high efficiency. And then this process that spawns multiple parallel threads. And then we have these multiple data lookup techniques, and I'd like to add a few others here too. And then this in-memory data summarization process that prevents us from creating huge extract files, which then have to be sorted. To the extent that we can summarize things in memory there, we have very much less to sort, and the whole process gets more efficient. So currently, we can produce these logic tables and view definition parameters files from information that's in the database that's accessed by the workbench, or by XML produced by the workbench, or by VDP formatted XML. But we might want to have our own programming language, which opens up a whole new realm of possibilities. So some people on the team and I have been looking at that. So basically, what we have here on the screen is the model that we have right now for version 4, which is currently ZOS only. On the left side, I've accumulated all of the pieces which we're going to think of as the front end. It's everything that the user interacts with. The workbench up here in the upper left, which is something that interacts with the database. The users can put metadata into the database and then call the logic text compiler to compile text into logic table codes. And then in the batch process, we have our MR91 process, which can take the information out of the database and then create these, what we're going to call run control files up here in the upper right, the join logic table, the extract logic table, and the view definition parameters file. And so basically, that's the interface between the front end and the back end. There's many different processes that could create those 3 files, but currently this is all we have. And then here in the lower left, we have these standalone processes that we use for debugging, the VDP analyzer and the logic table print process. Over here on the right is our latest version of the performance engine, which is somewhat stripped down from what other folks might remember, like Mike Perez. It's changed a lot since you've seen it, I think. So now we've got just 3 programs, the reference phase, the extract phase, and the format phase, just interacting with these run control files, which tell them what to do. And currently they can call COBOL exits or assembler exits. And so currently we're spread out over 3 or 4 different kinds of languages. Java for the workbench, C++ for these other front-end programs, and most of the rest of it is assembler, although we have a handful of COBOL exits also. So what we're thinking is that we could continue.
Randall?
Sure,
could I ask a question?
Yeah.
Is there a reason why you didn't list language environment C++ as a potential exit? I know we don't have those in our bailiwick today, but is there a limitation on that?
You know, we've never done that before. Actually, we've done a few little proofs of concept. We found that they do work, or at least I know that C works language environment C works. I'm not sure if we've ever tried C++ for exits, but that's a possibility. I guess I just wanted to list what we're using
That's
currently.
fine. That was my question. Thank you.
Yeah. Okay, so then we could continue to build on this process, continue to make the workbench even better, add some more features there, continue to enhance the logic text language that we have, but still be reliant on a database. And if we do that, we could continue to build new features with the time saved by not having to change over to another front end. The disadvantage is that we're still stuck here with the database. It adds complexity. We have to worry about database scripts to set up the new tables, stored procedures to interact with the database. And then there's all the maintenance of just having a database, backups and everything. And then also, this model doesn't lend us well for source code management. We've had many customers over the years ask us, well, how do we take these objects that you've created in the workbench and store them off in a source control system? And we've never really had a good answer for that. And so what I'm hoping with a redesign is to deal with those questions. So what a few of us are proposing is a version 5 of Geneva that looks something like this. Basically, the backend could remain the same, at least with this first iteration, as long as we find a different way of creating these run control files. And so what we could do is we could actually have a complete new language, and its sole purpose would be to create these 3 run control files. And it could be using this groovy language, which is a Java virtual machine compatible language that's open source, and it has some nice features for creating what we'll call domain-specific languages. And we kind of think of our little Geneva world as a domain-specific language. So anyway, what we envisage is a certain, well, some user could code a view rather than on the workbench. They would code it just in text in some kind of studio type environment. And we're proposing using VS Code as our initial studio environment, IDE type environment. And within that environment, you could call a compiler for this new GG language. And we could store views in source code. And it could include files like a logical record definition could be its own file rather than a structure in the database. We could also have called in files included in from for logical files, lookup paths, physical files, all the different structures that we're used to in the database could actually be separate chunks of code that we could just include like a COBOL copybook, say. And then in the process of doing this, we would get more Java oriented and kind of disengage ourselves from C++, which is starting to get a little bit out of style. C++ is almost as old as COBOL now, and is not as taught in the schools as Java is. So it might make more sense to get our front end more Java friendly. And we're thinking that in this environment, we could probably make use of some tools. There's a tool out there called Gradle, which is an open source tool which is used for building. It's kind of a substitute for BuildForge, or also job scheduling. And we're thinking that if we set this up properly with some scripts, we could use that to read our code, do a compile, and create these run control files, and all feeding into the same existing ZOS backend. Questions so far?
Hey, Randall, how business user friendly is that groovy? Because like for a lot of stuff that we did at HSBC, it ended up being not developers, but really finance creating views using the rule facility we had developed.
Sure. Okay, so I guess what we were seeing here is that if we have this base behind the scenes of source code, you can have multiple different front ends. So this would be a front end, the studio front end for the hardcore developers that want to have all the features. We could see a case where you would have your rules maintenance facility be able to, it could continue to generate the VDP XML that it does today. And we could build a very simple translator program that could take VDP XML and turn it into our new Groovy Geneva format. So
okay, so HSBC RMF rules could be exported and converted into Groovy.
Yeah. So the end users could still see the same screens they're using right now. They could just continue to interact with RMF. And then you could also still maintain your investment in those 20 COBOL programs that were written to read the rules and turn them into our VDP XML. And so we would maintain that technology for backward compatibility. But our translator program could take the VDP XML and pretty much just do a one-for-one exchange to our new GG language. And then so the end user really wouldn't know any difference. They'd still run the same backend, but we'd just introduce this layer here, which would allow us to have better source code management.
Mike, I just want to comment here. Your comment was exactly as I ran this through in a conversation with Dean Lima, if you remember him last week. He and I were catching up. His response was exactly the same thing. And as I talked to Dean, I said, Dean, part of our problem with the workbench today is it's kind of stuck in the middle. It's not simple enough for the business users, but it's too simple for complex developers. And so what we would, Randall, another way of saying it would be, we'd maintain the database structures we have today, and if somebody wanted to build their own front end that stores into those database structures and use the tools to create XML from that, we could then continue in the future to take from that XML and translate it or run it in some way. That opens up the business user simpler interface side of things, because that database structure we have is useful for that sort of business interface, a unique one for whoever wants to develop it. But this opens up a more powerful way for the more hardcore development as well. That's isn't constrained by the limitations on the workbench today.
Yeah, we had just before I left HSBC, split it into 4 different concepts, right? A security piece, a metadata piece, an orchestration piece, which is basically the run control stuff, and then the rules side. And with finance, really, changing rules on a daily basis and updating all kinds of things there. And what we were looking at the time was drools, which I think, Randall, you had looked at previously. Do you remember drools?
Yeah, actually, I don't really. Maybe Kip did.
So Raksh has used drools for the accounting rules engine.
Raksh, okay, yeah.
Raksh has used drools as the open source. It's a rules package, well suited for accounting rules type processing. Yes. Right.
And now switching roles, what we're looking at now is a drools rule facility. It's running currently for large government-sponsored entity. Let's just let's say that. The problem that they're having is their throughput. The rules are great. The users like to store the rules in drools, but they can't carry the freight.
Yeah. So what Mike, what that triggers in me is we'd be looking at, is there a drools to Groovy sort of interface, way of easily translating between those, because drools is a rules engine. Groovy as a language will probably be more powerful than drools itself, right? But again, if as we're doing this, Randall, we're opening up a different kind of user interface to get into the logic table and such, it would make this proposition even more powerful. Interesting.
Yeah, so as long as you could write a drools to Groovy Geneva translator, then we could have all the power of Geneva here based on whatever front end you want.
Yeah, okay. That's good feedback, Mike.
Ian here. I think I'm not on mute here.
No, you got your mute, Ian. Go ahead.
The problem with, no, it's not a problem, but the difference with the likes of the rules engine at your former employee and wherever you happen to be now, is that those rules are all very domain specific. So you're dealing with issues and things that I don't even understand. accounting rules, etc. So gearing our language or studio or whatever to those things requires that domain knowledge. So there's a gap in the process there. So yeah, if we could somehow specify something to be generated to feed into our world, that would be great. That would be what we need.
Yeah, and to your point, if I were to restate that, right, we certainly wouldn't want to use specific field names, hard-coded field names and that sort of thing within a rules environment for our language. We want to keep ours more metadata driven so that it can be domain independent, right? And so what we'd be looking for to go from a translation process from drools is we want to be looking for the basic functions that drool performs, which has if functions that are anded and order precedent sort of things. That fits into most languages. It has assignment processes, those fits into language as such. So I think we're looking more for that generalized drools interface, not a specific domain drools interface that would come into our GG, our source code, our Geneva Groovy language process.
Sure.
But to your point, Mike, if we looked at that, and there's a value here, Randall and Ian, Raksh's front end, he has a very nice user interface that's basically like an ERP system. He's expressed interest in having an execution engine that executes on Z. And his backend execution engine for some portion of it is Spark, which I've talked a bit about, how to think about integrating that perhaps with MR95 and the performance engine. The other piece that he's using is drools for the accounting rules engine, which we never really added on to SAF or Geneva. But if we facilitated both of those are his two major engines in his platform, it would open up the capability of someone specifying logic in his user interface and execution on another platform. So that would give us another independent entry point into execution of our engine.
Yeah, if we somehow had some sort of drools translator,
Yes.
that would be great.
Yep.
I know nothing about drools at this point.
Nope, that's good. There's some research.
Other than I picture things dripping down my chin.
Nope, that's Mike. That's what we need to take away from here is those sort of suggestions that cue us in as to how to refine this further. It's a good discussion there. Thank you.
Hey, Kip.
Yeah, Andrea.
Your secretary is looking at the time.
Thank you, Andrea. Press forward, Randall.
Okay, well, let me see if I can cut to the chase here. Okay, so basically, Mike and the rest of you, what we were thinking is that if we switched over to this language, we could now have a window to source code management and make this more of a tool like a traditional tool where you can version things and do source code comparisons to see what you've changed. So we think that's a better model to build for the future on, rather than taking our existing Workbench database model. So that's where we're headed with that. Anyway, disadvantage is that, yes, maybe we'll get rid of the C++ programs in this process, but we'll still have to continue to maintain them for the existing clients. So can't divorce ourselves from that immediately. Okay, so now here's another option, is that once we switched over to this new front end, then we probably have a better platform for the future to change the back end to be Java virtual machine compatible. So rather than running everything in assembler, we could recode these things in some JVM compatible language like Java or Scala or Groovy. So we'll see if somebody wants to take that task and move that forward. So we could maintain the same front end, different backends depending on your choice of platform. Okay, And then, so we're thinking that this alternate backend would have the same advantage of the ZOS backend, except it probably wouldn't run as fast or as efficiently, but some people would prefer to have just the options of switching to different platforms. And it also might be more attractive to open source contributors. And then here on this last slide, I think, Mike, this is the thing we were referring to before, alternate user interface with a GG compiler and GenevaERS backend. So basically, you could have like a rules maintenance facility or probably lots of different inputs as long as we can find a way to just compile to the GG interface, which means you have to have some basics like the predefined lookup paths and things like that. Anyway, and another technique is you could have a GG Studio front end with a translator that gives you different backends instead of our traditional Geneva performance engine. You could have generate Java programs or Spark programs out the back end. So that's what I have to say about that. Back to you, Kip.
Oh, that's excellent, Randall.